In this video, I'll show you how to solve the next set of problems given by official ACT. Okay, so the first example says the lead of a screw is the distance that the screw advances in a straight line when the screw is turned one complete turn. If a screw is 2.5 inches long and has a lead of 1/8 inch, how many complete turns would get it all the way into a piece of wood? So once again, let's look for keywords. So what is 2.5 inches? 2.5 inches is the screw length, right? So let's just label it as 2.5 length of a screw. Okay, that's 2.5. Now, what is 1/8 inch? So 1/8 inch can be expressed as, well, let's just leave it 1/8. 1/8 inch. What is that? That is the lead, right? The lead, and what is the lead? Is the distance that the screw advances in a straight line when the screw is turned one complete turn, right? So lead distance, okay, for one complete turn. So we're trying to see how many of these turns are needed so that the entire distance of the screw itself, 2.5 inches, is covered, right? When it gets all the way into the piece of wood. So what do we do? Since this is the total length and this is one complete turn length, we can basically think of it like this. Think of it as a number line, for example. Well, think of it as a line segment, rather. And think of it as this being the endpoints making it 2.5 inches, right? 2.5 inches. 2.5 inches. Now, if you divide this into, let's say, into 5 equal parts, each of them can be x inches, right? X, 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 right? So 5x would be equal to 2.5. So in order to find the x, you would need to divide it by 5, right? So in this case, 1/8 inch represents the x value, right? Because there's a certain number of these 1/8 inch lead distances that will make it into a full line segment, right? From this endpoint to the rightmost endpoint, right? So let me just erase this. Well, I'll erase it at the end. So let's solve it algebraically. So all we have to divide 2.5 by 1/8. Okay? So you can use your calculator, or you can, if you remember that 2.5 1/8 inch represents 0.125, right? If you remember that, you can win time on your calculator, because if you divide by a fraction, you'll have to use parentheses in your calculator. But anyway, do the best you want, do the best you can, or whichever method that works for you. I get 20 for my answer, right? So that should be the correct answer, 20. Okay, next problem. If xy is equal to 144, and this is the product, x plus y is equal to 30, and x is greater than y, what is the value of x minus y? So first, notice that it's interesting because x, y, and x plus y make me immediately think of squaring the x plus y, right? And why is that? Because if you square it, this is what you're going to get. X squared plus 2xy plus y squared, right? So, and what is that equal to? X plus y is equal to 30. So if you square that, you get 900, right, on the left side. And guess what? Now 2xy can be used because xy is equal to 144. So we're going to get x squared plus 288, that's twice 144, right? 2 times 144 is 288, plus y squared. So that means x plus x squared plus y squared, if you subtract 288 on both sides, you will get 900 minus 288, right? Which is equal to 612. right? 612 is equal to x squared plus y squared. So now you might say, well, what does that do for me? I mean, I need to find x minus y, right? Well, here's the trick. Realize that the sum, if you square a polynomial x plus y, you will get x squared plus 2xy plus y squared. But what if you square the difference what if you square a similar polynomial, only that you will subtract y, right? You're going to square x minus y, in other words, right? What if you do that? What if you do x minus y squared? You will get x squared minus 2xy plus y squared, aren't you? And guess what? You know what x squared plus y squared is from here, and you know what minus 2xy is also, right? So x minus y squared is equal to, now let's substitute in the numbers, right? X squared plus y squared, I'm summing up the first and last terms, is 612, right? And then subtracting twice xy. What is twice xy? That was 288, right? So minus 288. And what do we get? Is equal to minus 300 is 312, plus 12 is 324. And guess what? 324 is a perfect square. So if you solve for x minus y, you're going to take the square root like this. X minus y squared. You'll take the square root of that, so you're going to get a square root on both sides. So you take a square root of 324. And guess what? Is equal to 18. And of course, you could have done that using your calculator. I mean, you don't have to memorize that 324 is a perfect square. You can always use your calculator for that. Okay, next problem. In the figure below, angle ABC is congruent to DFE, and BAC, angles BAC and FDE are congruent as well. So let's mark them. So I'm going to mark them like this with different colors, so that you can see that they're congruent. Okay, and D and F are on AB, right? So D and F are on AB on the same line segment, and then AD is equal to FE, right? So these segments, let's mark them X's with a different color actually. Let's mark them X's. AD is X and BF is also X, and FD is 6, right? Distance is in centimeters. What is the length of AD in centimeters? Now guess what? Since these sets of angles are congruent, these pairs of angles are congruent, it's already enough to tell that these two triangles, right, the smaller one inside and the parent one, the larger one, they're both similar triangles. So when the triangles are similar, you can use proportion to relate its sides, their sides, respective sides. So what do I mean by that? I mean that you can take AB, okay, divided by FD, and set it equal to AC, dividing it by the smaller counterpart side, which is 12, which is DE, right? DE. So now notice that I'm keeping the consistency here. I'm showing consistency because I'm starting with the larger triangle side AB, dividing it by the similar side FD, right? Corresponding side FD of the smaller triangle. And again, in the second fraction on the right side of the equation, I'm starting with the larger side again, the second larger side of the larger triangle AC, and dividing it by the similar side 12 DE, right? So I'm showing consistency. So the top sides, the numerator sides, are the large triangle sides, and the bottom sides, right, the denominator sides, are the sides of the smaller triangle, right? The similar triangle, smaller one. So now if you set it up correctly, and notice that you could have done it differently as well. I will show you which one is correct as well. So you can do AB and dividing it by AC, right? So if you choose to have a fraction only dealing with the right with a large triangle, you can do that. But then the right side must deal with the small triangle only as well, right? So if you divide AB by AC, then you'll have to divide FD by DE. That will still get you the correct answer. Okay? And notice that if you perform cross multiplication, you will have AB multiplying DE, and you still have that consistency. AB multiplies the DE. You see? And FD multiplies AC, and the same thing is happening here. So you didn't violate anything. You actually were correct. You might say, but what if I switch? What if I decided to do AC over AB? You could do that, but then this guy would have to be switched as well. It would be DE divided by FD, and still the multiplication, the cross multiplication, would still yield you AB multiplying DE and FD multiplying AC. Okay? But just for now, I'm just going to erase it because I don't want to create too many fractions, unnecessary fractions, because we're going to be substituting in the numbers for the sides that we know. Okay? So let's substitute in these numbers, these sides. So AB is equal to, how do you express AB, by the way? So I'm just going to write AB is equal to AD plus FD plus the remaining one, BF, right? And that's equal to X, right? Plus 6 plus X. So that's 2X plus 6. Okay? So now it's easy, right? Because now that's the only variable that we see, and we have to solve for X, right? Because X is the AD, that's the question asked. Right, so now let's substitute these sides with what we know. So 2x plus 6 divided by FD. What is FD? FD is 6. Is equal to AC 20 divided by DE. Where's DE? Right there, 12. Now cross multiplying, the product of the means is equal to the product of the extremes, right? That's going to be 24x, right? So we're multiplying this pair, right, and then setting it equal to this pair, right? So it's going to be 24x is equal to, oh, well, sorry, I forgot to add one more. 24x we distribute, right, plus 72. Sorry, I'm writing with different colors, but don't worry about it. I mean, you can still see the work. Is equal to 120, right? Subtract 72 from the 120, you'll get 24x is equal to 48. I'm not even using the calculator, and I know that 27 is exactly 1/2 of 48, right? So x is equal to 2. That's your right answer. And don't mind me working so long because I'm showing you how to see the problem, right? I mean, I would not have to do all this on the exam. I would do it in the blink of an eye, basically. But I'm just showing you how I see this problem so that you can do it on the actual test really fast, right? So that it clicks in your head that you've been there, done that, right? Okay. So the last problem on this in this set is going to be, which of the following is a factor of the polynomial 2x squared minus 3x minus 5? So two ways that you can do this. You can either take too much time by simply dividing this polynomial by these potential factors, candidates for these factors, and see which one gives you remainder 0, right? But I would not do it that way. I would just factor this guy, and then whatever the factors I get, I would just find one of the factors here in the multiple choice available, right? So how do I factor this? So let's understand how we can factor something. So we're gonna look at these two guys, 2 and -5, and we're gonna multiply them together. So factors of 2 times -5, so that's -10, that sum up to the middle guy, the -3 coefficient. -3. So what are these factors? right? What are the factors of negative 10 that sum up to negative 3? Well, you know what? They're exactly these two numbers, because negative 5 times 2 is negative 10, as you already see, and negative 5 plus 2 is negative 3, right? So what we do, we're going to break this up. We're going to keep the first term, 2x squared. Now we're going to break up the negative 3x as a sum of 2x and negative 5x. So we're going to have negative 5x plus 2x. Right? I'm going to use a different color so that you can see it. So 2x squared minus 5x plus 2x. And then finally, the last term as written, right? Minus 5. So what does that do for you? Now you're going to factor it by grouping, right? Notice that you can have x placed outside. You can factor 2x squared minus 5x as 2x minus 5. Right? Already I see 2x minus 5, but let's finish this. Then we can have plus 1 times 2x minus 5. You see how I did it by factoring by grouping? Grouping means I'm taking this group and I'm then taking this group, right? And this is what I get for the first group, and this is how I factored the second group. And 1 times, right? This is 1 multiplied by 1 times. So now, if 2x minus 5 multiplies both x and 1, and we have a plus sign, it means that we can basically sum up the x and 1 and have that sum multiply the 2x minus 5, right? So we can basically have 2x minus 5 being multiplied to x plus 1, right? It would still give us this answer, right? So your suspicions were correct that you thought that 2x minus 5 was a factor. It's indeed a factor of this polynomial. Thank you so much for watching, and I'll see you in my next set.